All right, we are going to go to slide number 4 now in the same file for lesson 4.4, Euler circuits. Now we're going to be looking at new types of graphs. We're going to be looking at graphs that have direction to them. Okay, so look at this graph right here. See these arrows? See the arrowheads? These graphs have direction to them. The arrowheads mean that you could only travel those edges in the direction of the arrow. Think of them like one-way streets, okay? You have to follow the arrows. You cannot go against the grain of an arrow. These are called digraphs. Digraphs are directional graphs. So what we have to analyze now at each point, whereas before we analyzed how many roads lead into and out of, or how many roads touch each point, now we have to analyze how many roads are leading into and out of each point. Okay, we have to analyze what are called the in degree and the out degree. So at point A, how many roads are going into it? So just count the arrows going in. So there's this arrow and this arrow right here going in. So it's got an in degree of 2. And then how many arrows are going out of point A? Well, there's also 2 going out. There's one going this way and one going this way. So it's got an out degree of 2 also. Okay? That's a good thing when they match. See how the 2 and the 2 match? That's good. Okay? So let's analyze this at each point. So at point B, the in degree is 2 because there's 2 coming in. And then the out degree is also 2. All right? Point C, in is 1, out is 1. Point D, in is 1, out is 1. See how they all match? 2, 2, 2, 2, 1, 1, 1, 1. That makes this a circuit when they all match. All the in and out match. Okay? Which means that you could start anywhere you want in this graph and you will get back to that same exact starting point. So like suppose I start here, point C. Doesn't matter where you start. If you follow the arrows, you will get back to point C. See that? We've traced over every single point, every single road, and we started and ended at point C, which makes this a circuit. So if all the ins and outs match each other, you will have a circuit. All right? Now, scroll down a few slides to example number 10. All right, let's do this one now. Let's start analyzing the ins and outs at each point. So at point P, the ins are 2 and the outs are 2. Point M, the ins are 1 and the outs are 1. Point K, in is 1, out is 1. However, point N, in is 2, out is 1. And point L, the in is 1 and the out is 2. All right? So 3 of the points match. This, and this all match. However, this point and this point do not match. There's one extra in. There's an extra in here. Right? And there's an extra out here. When that happens, you're going to get a path. It's not a circuit anymore. It's a path, which means you're not going to be able to start at the same point and end there also. You're going to have to start. So a path means you start and end at different points. And more specifically, when you have these in and out graphs, you will have to start at the extra in. Start at the extra out. And you will end at the extra in. Which should make sense intuitively to you. Because if there's an extra out, so like at point L, there's an extra out there. That means you have to start there, which means you're immediately going to utilize one of the extra outs. So like go that way, and then go around, and around, and around. Follow the arrows, come this way. And then look where we end up. We end up at point N, which is the extra in. You'll always start at the extra out and end at the extra in. You'll end at the extra in because there's an extra in waiting there, and then you don't have to exit that point again if you're ending there. So you'll utilize that extra in on the final inlet to that point, and then you don't have to move it again because you'll be done completing the graph. So you'll utilize that extra in on the very last in. Okay, we'll stop this video there and we'll